Hello, everyone. Welcome to the People of Aquaponics, where we get to know industry thought leaders. And today we're fortunate to have Paul Brown. He's a professor of fisheries and aquatic sciences at Purdue. He's done research in aquaculture, nutrition, aquaponics, and he currently teaches aquaculture and physiology at the aquaponics at Purdue. In terms of his research, he's expanding its scope to international applications, currently in Guatemala and Zambia, and who knows wherever next. From interacting with Paul, I could just see he's passionate about the developing context and improving sustainability of aquaculture diets, and especially with the use of the locally available agricultural products. As of right now, he's basically just gone through an Arctic storm of sub-zero temperatures and freezing blizzard and apocalyptic conditions. So he's coming to us from his home in Indiana. So Paul, glad you could join us today. How is it going over there?
Good to be with you, John. And I appreciate the opportunity to meet with you. Always enjoy interacting with you. Our snow front and snowstorm was not what we expected. We're expected to get up to a foot of snow in 30-mile-an-hour winds. I don't think we've got more than probably 6 inches, maybe. But the drifts are pretty deep. So all schools have shut down. Purdue is even shut down for today.
Oh, so you get a little vacation then, except you're all online now. So.
Yeah. I've got a 2-hour meeting later this morning with students, so yeah.
Okay. Well, I was hoping you could give us a little overview of how you got to where you are and how you arrived with aquaponics.
Well, the first aquaponics system I saw was a colleague of mine, as a graduate student, in 1984. He had set up just the standard tilapia, tomato, green pepper, leafy greens kind of system, ran it. We poor graduate students ate very well, helping him with his project. But I've always been a bit surprised that it didn't explode, quite frankly. It just makes a lot of sense in terms of food production system. I've kept that in the back of my mind for the 30-something years that, I just got a report that we got officially 8 inches of snow last night. Oh, 10 inches of snow. Yeah. We got more than it looks like. Anyway, I've been a bit surprised that it hasn't grown as much, but I'm surprised that aquaculture doesn't grow either. I've been focused on aquaculture research now for a little over 30 years. And quite frankly, as a research scientist and teacher, I have to go where the dollars are. And there haven't been any dollars in research funding for aquaponics. It's been more in aquaculture. And we've been doing that and producing students and research papers and things like that right along the way. And yet in the US, we don't see a real increase in aquaculture. And again, that's another one I can't explain. There are the biological limitations have been removed. Every fish species we have tried to grow here at this latitude, whether outdoors or indoors, we've been able to grow. So and yet the industry is not increasing. So I could continue the rest of my career, continuing to improve productivity, efficiencies, etc. More in the vein of what the agronomists do and the animal scientists do with the established big food production systems. Or I could try to get into something new. And quite frankly, I'm a lot more interested in something new. There's still very few research dollars for aquaponics, and yet I'm less concerned about that than I am about how we feed the 10+ billion people we're expecting in the next 30 years. These numbers just really jumped out at me. 30 years, we have to double food production to meet the demand. It's not just population, it's also changing food habits in China, India, Sub-Saharan Africa, other places as well. And we're currently using, UN FAO estimates are that we use 70% of the global supply of fresh water currently to produce this food that we are producing? Well, if we have to double food production, we can't double 70 very well. Math is not my strong point, but it's we have to do some things differently. And I have, every time I talk about this, I call it one of the world's great new ironies. The food production system that uses less water to produce more food on less land is a water-based system. It's an aquaponics system, which is intuitively incorrect, and yet there it is. The numbers are there. They're continuing to develop. Excuse me. We know that this system works, and I'm going to be very surprised if in the next 30 years, which is a short period of time, I think I'm going to be very surprised if aquaponics doesn't become a major component of overall food production systems.
So with your kind of oversight and the way that you are able to tap into different industries in your position, how do you see the aquaculture industry changing, and how is it changing with the integration of a more hydroponic production system?
Aquaculture is a bit of an enigma. We have tremendously marketable species, for example, like here in the US, in the EU as well. Native species, they have good name recognition, strong market characteristics, strong market acceptance, and yet the industries have not increased to any significant extent. We're seeing actually a decline in the major industries in the US. There are a few that are growing, but they're the really easy ones on the coast. They're largely mussels, scallops, oysters, most of the bivalves. The fish component is simply not growing. It is in other parts of the world, and the American consumer seems perfectly happy importing those products. Even though we hear in the popular press, oh, imported things are bad, and oh, they could be contaminated, and they could be this, that, and the other. Well, most of them are coming in pretty good shape. So it's a good quality product. A lot of market characteristics that are driving acceptance, of course, are price points. They're coming in here at lower prices. Period. End of story. The American consumer will take a good quality product at a low price over something that's grown here and might be a higher price. So again, we're just not seeing it. We're seeing a desire or an acceptance of imported food items, and this is not unique to seafood. This occurs with a lot of food items here in the U.S. And again, I've always been a bit surprised at that. I would have thought public policy might try to influence local production, and I think they would be building on the current consumer trends. A lot of those consumer trends are indeed fresh, locally produced products. Instead of bananas and blueberries and apples ripening during transport to market, most people, if given a choice and a similar price, they prefer to have a fresh product. I've argued that most of the people here in the central part of the U.S. Have rarely had a truly fresh seafood product. Almost all of it has been frozen somewhere along the way. So it's, and again, the taste difference, the quality difference, et cetera, is clear and distinct. And I don't have a discerning palate at all. But I can tell when a product's been frozen. I can tell farm raised from wild caught, things like that. So it's we've got an interesting situation, and aquaculture has done some things that have been disadvantageous to themselves. They remain in a battle with wild caught fisheries, when the fact of the matter is all of these products go into the same market, and they can be distinguished in those markets. And we have a lot of products that are illegally labeled in this country as wild caught, because wild caught, the perception is wild caught is better. And yet every animal product that we consume on this planet is raised in an agricultural setting. But all of a sudden we don't like farm raised fish, we like wild caught fish. Well, I like both personally. But we certainly don't like wild harvested cows or pigs or anything else. So aquaculture has not done a good job of defending itself, of fighting back, of claiming its place in the total global food supply? I know it's a question that you asked me to comment on here a couple of weeks ago, and I've deftly avoided that so far. But I think it is a pertinent one. It was a really good question because aquaculture has not gotten into the fold. They have not gotten into federal programs, international programs, et cetera. They just kind of stand on the sideline and say, well, here we are, we just do our thing. They don't get integrated back into the global food supply very well. Aquaponics, by its very nature, is integrated back in the global food supply much better. I see a lot of differences in the peoples who are doing it. I don't see a lot of aquaculture people integrating aquaponics just yet. Although I met with large owners of some large sturgeon farms out in California a couple of years ago now, and they wanted to integrate their entire operation. And this is a large both outdoor and tank culture and indoor operation with sturgeon. And their sturgeon are just amazing. These are big female fish. I mean, they've got them every year, full of eggs. So this place is really making a lot of money, and they want to primarily integrate outdoors to produce a secondary crop, high value crop in the California market. All their products are going live into San Francisco right now, and they want to put plants in to clean up the water. It's that simple. It meets a filtration need. It produces an extra product. They've already got regular deliveries into San Francisco, fresh, locally grown kind of markets, et cetera. I think it's a no-brainer that they should just do that, and I encourage them to do it. I haven't been there to talk to them a couple of years, but I hope they have. But I've always been surprised that aquaculture seemed to make just some very simple policy types of mistakes by not getting integrated in the larger global food supply issues, by competing with a very similar product instead of banding together to market both products and then let the consumers decide.
That's good. Yeah. So one of the critiques about aquaponics is the kind of source of the fish feed. And I know that you have done a lot of research in this area. And so I was hoping you could shed some light on maybe some of the difficulties with that conversation and how you see the industry moving forward.
Yeah, we have to start the conversation with the fact that the feed input is one of the most expensive components into the system. So it's an economic consideration. So when we talk about alternative ingredients and all these types of things, that's all great, and yet it's going to affect price. And if it affects price, that's going to affect then the bottom line, cost per unit pound of product produced. So it gets to be, we have to start there. And we've known from my very first exposure to aquaculture nutrition, which was a long time ago, the fish meal component was problematic. It's called the fish meal dilemma. It remains one. We know that it's a great food ingredient, dietary ingredient for aquatic animals. Big fish eats little fish. I have lots of slides on that. I show those in most of my presentations. If you feed a fish another fish, they grow really well, and it's near maximal rates. However, we've known it's been a finite resource since the late 1980s, early 1990s. The only question was when demand would exceed supply, and when that happened, of course, price is going to go up dramatically. And we're in that situation now. It's gone up dramatically. It's not going to go back down. We are harvesting at maximum sustainable yield all the forage fishes that we can to make fish meal. We're not going to get any more. So alternative protein ingredients has been a focal point of fish nutrition research since I've been here. I'm surrounded by corn and soybean farmers, and they have a lot of research dollars. So we got along really well for a lot of years and still do. Soy products work in fish diets, but you have to be careful about the concentrations you put in diets. Some fishes are more sensitive to some components of soybean meal, more so than others. Some are very tolerant. So it's very much species specific. And we've defined where those upper limits are. So we know what those upper limits are, and the feed formulators can just keep it below those levels. And the beauty of a globally traded commodity like soy products is that the volume is so high on a global scale that the price is reasonable. So the price is low. And that group, as a complex, as a soy complex, they've done an amazing job at keeping supply and demand, supply right at the point of demand, which a soybean farmer complains constantly about the volatility in price in soybeans. Okay, well, let's put a frame of reference on this. They're talking about volatility from $8.50 a bushel to $9.25 a bushel. Okay, that's huge volumes for them, huge issue for them when they're talking about the volumes they're dealing with. And yet we've seen in my professional career, we've seen fish meal prices go from as low as $300 per ton. It's now trading over $1,200 per ton. And again, it's not going to drop back to $300 or $500 or $600 per ton. It's not going to happen. So yeah, they're an interesting group to work with, and their idea of price volatility in a commodity world is far different than the one that we deal with. So we would describe a soy product, a wheat product, a canola product, pea proteins are really cool protein sources too. Lots of them out there, plant-based protein sources. When we talk about price volatility, I describe these products as very stable, very stably priced. So your feed prices don't go up very much. Then the other side of the coin is we've evaluated some of these two are the animal byproduct meals, poultry meals, poultry byproduct meals, feather meals, things like that. On the terrestrial animal side, the mammalian side, we've got meat and bone meals and things like that, and pure bone meal. Blood meal is a traded commodity, very high protein concentration, but very limited application in fish. They just don't tolerate it very well. The animal byproduct meals are objectionable to some peoples for a lot of different reasons. So we can't use those in certain situations. But the blend of a relatively low concentration of animal byproduct meal plus a plant protein ingredient actually gets very close to meeting the protein and amino acid requirements of almost all fishes. So it's there. We can go fish meal free, and we've known we can go fish meal free for a long time. But the customer is a bit concerned about it, the producers. They want to do that. They recognize the benefits in terms of marketing and sustainability and perceptions and all these various issues and even price stability. But all of a sudden the color of the pellet is different. And anytime you switch diets on a fish, they tend to decrease consumption for about 3 to 7 days, which scares the heck out of a fish producer, and rightfully so. But it's that consumption, that maximum consumption, commonly comes back up to where it was prior to switching diets. So we've got I really enjoy my professional interactions. They're actually a lot of fun. It's fun to watch, understand how people do what they do and why they do it. And then my job is to do the research to try to provide them some options and some answers and train some students and get them involved and all that kind of good stuff.
That's great. And I think you touched on something really important, is that you're looking at like a multifaceted approach to fish feed and the commodity world. And so I'm just wondering if you can tell us a little bit more about your work. We know you're passionate about the developing world and trying to help it become more sustainable and increase the nutrients in the diets. And so how does this play into kind of your work and research?
Yeah, let me talk a little bit about my two current graduate students, both PhD students, both candidates now. They both passed their prelims. Should be wrapping up maybe here this December. One's working on freshwater systems, and he started out wanting to do cold water systems with rainbow trout. got into the literature and found that the topics he really wanted to pursue would be more appropriate, more germane to a warm water system. So he switched over to a tilapia system, various plant species. And he's looking at discrete periods of time in the operation of an aquaponics system. So he started with startup. What kind of water needs to go in there? What's the effects on the fish? We work very closely with some hydroponics people here at Purdue and the Department of Horticulture and Landscape Architecture. And they always start their systems, and I understand a lot of hydroponics producers start their systems with reverse osmosis water, RO water, which is almost devoid of ions. So there's no mineral nutrition in there for the plants, but then they add back very specifically the minerals they want for the plants they're growing. Well, that's great, but RO systems are expensive. They're difficult to maintain. I mean, the ones in analytical labs commonly break down. You have to buy new filters for them, et cetera, et cetera. So Ping got into the discrete unit of time when you start the system up, and he compared RO water to well waters and then adding back several different ions. And one of those treatments, we were pretty sure was going to be a negative control. We thought the fish were not going to like this at all. This RO water doesn't have sufficient ions in it for a fish to osmoregulate at the gill. This should have been quasi painful for the fish. And we're going to let them go to the point of dying. We don't do that, but we were watching them very carefully. And guess what? They lived. They lived and they grew well. In fact, it's one of the most rapidly growing treatments that we had, which violates everything we knew about standard generalizations about fish physiology and osmoregulation. So, I mean, my gosh, I love doing research because all of a sudden something you expect just doesn't happen. So he's out now looking at some other discrete unison time, et cetera. Yu Ting is working on marine aquaponics, marine shrimp, and various salt tolerant plants. First study she did that's out now in print was optimal salinity. And a lot of our marine shrimp recirculating aquaculture producers here in the US are operating at around 10 to 12 parts per thousand, as opposed to full strength seawater, which is about 35 parts per thousand. So it's brackish water conditions. And indeed, the shrimp and the plants both grew best at that brackish water condition, which is good. And we're having to make seawater with salts. The salts are not cheap. They cost money. So if we can operate and have maximum growth and product output at a lower salinity, that's great. The benefit of a marine shrimp is that the economics of an aquaponics situation changes significantly. The people who are producing shrimp and the recirculating aquaculture systems, the biofloc systems here in the US, are producing as many as 3 crops per year. They grow that rapidly. So all of a sudden, if you have 3 crops of marine shrimp at a high value coming out of an aquaponics system each year, compared to a fish crop that doesn't start getting to market weight until 9, 12, 15 months, depending on species, size you start with, et cetera, that changes things significantly. So I'm really excited about the marine aquaponics thing. I really like Ping's approach. Now on the developmental side of things, I've been a little bit disappointed in a lot of my colleagues, as well as the system overall, on how we get foods to peoples who need food. And there's still an awful lot of people on this planet that are simply don't have enough food. And it's one of the interesting aspects of aquaculture and fish production and aquaponics is that those peoples who are malnourished and are starving around the planet, they have a history and a preference for eating seafood. Whereas we in the US, for example, our seafood consumption is at 16 pounds per person per year, and it hasn't changed since I first saw that number. And it never moves. It's always 15 or 16 pounds per person per year, despite what our doctors say, despite what human nutritionists say, that we just don't increase our seafood consumption. those peoples who are literally starving have a history and a culture of eating seafoods. They want seafoods. I don't think it's related to necessarily to high quality nutrient intakes. I think it's simply it's in their culture that they eat seafood products. So aquaculture has been a component of U.S. AID programs for a long time. AID is the Agency for International Development. I've been kind of disappointed over the years watching USAID development programs. There's a strong focus on aquaculture, fish production. It's an easy thing to grow. It's culturally acceptable in a lot of these parts of the world where food is insufficient, nutrient intakes are insufficient. But they want to apply a Western, what I'm going to call a Western model of development. The Western model is have fish, buy a formulated diet from a feed mill, feed that to the fish, grow fish up, sell the fish, or consume the fish. Well, in most of these places that are food deprived and peoples are malnourished, buying fish feed is it doesn't make a lot of sense. A company could go into Guatemala or Colombia or Zambia or wherever it might be and set up an operation, yes, and buy the feed. They have the money. But for smallholder farmers, the small farmers are simply trying to produce food for their family or even produce a little bit extra that they could sell for an income. They can't afford to buy feeds. So this Western model has been the one that's been pursued almost exclusively through USAID programs. And the argument, it's a legitimate argument, and in theory it makes sense. It's in that you create jobs. You start a fish farm, you hire employees, you buy feeds, you raise fish, sell fish. So you create jobs, and then the economics of that family who has a job improves dramatically. They can then go buy food and things like that, and necessities, and medicines, and see doctors, et cetera. So that's all well and good. But what we're actually documenting now, I haven't been involved in this, but several places now have documented that the nutrient intakes in the local populations where these types of ventures have been pursued aggressively, the nutrient intake in local villages and local regions actually declines. Because what types of foods then are they going out and buying? Well, they're going out and buying a Western style diet, which has been documented time and time again. It's not a very healthy diet. I eat it. My children are eating it right now. Yes, we all do it. But the carbohydrate intake, the fat intake, the salt intake, we know this is not the best quality food that we could intake. Yeah, we know this. But we do it anyway. Why? Well, availability, price, the same types of things that we get around to when we talked about with seafood. So we do this even though it's not in our best interest. But anyway, I think there's a middle, an intermediate type of production scenario and system that would actually benefit the local cultures better than this Western model of buying feed and growing feed. And then most of these fish that are produced in this Western model are sold in the urban areas, or there's a strong desire for export. And the governments of those countries encourage export to generate more dollars for their governments. So again, the local peoples aren't really the focus of all this. It's about generating dollars for other groups, for companies and governments. And I'm not anti-government or anti-corporation at all. I recognize, again, the benefits of creating jobs. This is all a good thing. But we've been exploring an intermediate approach, an intermediate between formulated diets from feed mills and no feed input at all. I mean, that would be a wild situation, and we've got people still harvesting a lot of fish and seafood from wild situations. Just have to be careful about not over harvesting and making sure you got a sustainable harvest number that you can rely on. But I think there's an intermediate, and that is using locally available agricultural byproducts from the surrounding area. If we knew the chemical composition of those products, and that's where the real challenge lies. That's why I haven't responded yet to the Aquaponics Association board question about this intermediate area, because it's a lot more complex. Is it doable? Absolutely it is. but the chemical composition of the various products needs to be known. When I sit down to formulate a diet for a target species, I'm concerned about 45 different nutrients and their concentrations. So we can talk about feeds, and most producers and practitioners talk about proteins and fats, and that's about as far as it goes. The aquaponics world is far more astute. They recognize there's some mineral needs in the plants that need to be met. So they've got it. They've got a sharper focus than we see with other animal production industries or in the aquaculture arena. It's enjoyable to work with them, but then they're leaving out the vitamins for the animals. So I mean, there's so many different nutrients we have to worry about. So a detailed chemical analysis has to be conducted. And then you've got situations in which you've got wet and dry seasons, for example. Those products will not be uniformly available throughout a 12-month cycle. The composition will likely change over a 12-month cycle, whether or not they're fresh, whether they've been dried, how have they been dried, have they been stored in good conditions, has it got mold, you can get aflatoxins. So we get into all kinds of interesting issues that are potentially dangerous. So I'm convinced that there is an intermediate way of pursuing this. It doesn't require buying expensive feeds. It's more designed for subsistence types of farmers or small farmers looking to sell locally to improve their own family's feed inputs into their households. And yet it's been a hard one to get going, quite frankly. Excuse me. We got through an NGO here in the U.S. We got one evaluation going in Guatemala, and it worked. It worked really well. Again, it's just knowing the chemical composition of identifying the agricultural byproducts that are available, and these are banana leaves. And it turns out there's a big cricket population up in the mountains of Honduras. So we have collected that cricket and grew some crickets and made a meal out of them and fed them back to tilapia. And banana leaves and moringa leaves and all kinds of fruits that were not acceptable in their present form, rotten fruits, all kinds of interesting things that you can dry, grind up. You have relatively safe ingredients then, mix them into a giant sticky ball of some type, and there you go. You're feeding fish, feeding them fairly accurately, and at the same time at virtually no cost other than your time. Now, the question would be, are you going to get maximum weight gain with this approach? And the answer is probably not. And indeed, we only had a couple of years to work on this, which I know for people outside of research, that sounds like a long time, but in research settings, a couple of years is not a very long time at all. We got close, but we've got some recipes now, essentially dietary formulations, so that we can guide and recommend to folks in that area how to put these things together in the right proportions. And yet they're producing high quality seafood products. Again, not maximum weight gain, but pretty close to it. So that was, I was a bit surprised and pleased that we're able to get as close as we were. One of the real common questions, just to go back for a second to the fish meal dilemma, is we constantly get the question about if we go with fish meal free, it's better, it's less expensive, it's more sustainable, it does this, that, and the other, and we'll get better growth. Our fish producers think we're going to get better growth if we go away from fish meal. That is a virtual impossibility. It's again, feed a fish, they're going to grow maximally. If we can match that growth, that would be great. And that's actually the goal. We're not going to exceed it. So with this intermediate approach, using readily available agricultural byproducts, if we can get anywhere near maximum weight gain, that's going to be awesome. There'll be times probably when we're at maybe 50 or 60% of maximum weight gain. Also got to keep in mind, though, in a lot of these cultures, they're not looking for what a developed country, EU or US, would describe as a marketable size fish. There are a lot of cultures around the world that need food of any size, shape, form, or fashion. So all of a sudden, instead of a 500-gram fish that might be marketable in the US or the EU, or oh my gosh, what a 6 kg salmon, whatever it might be. All of a sudden a 50 gram, a 100 gram fish is a incredibly important and valuable feed input for these villages, these areas. And there are cultures around the world that is what they consider marketable size.
I can't thank you enough for that research that you've been working on. And we really appreciate all that hard work that you've put into that, and look forward to seeing more about where you go with those different research facilities.